Today we're going to be talking about section 4.3, which is on solving quadratic equations by factoring. Now we've talked about how to solve quadratics by graphing, but another way to solve them is using what's called the FOIL method. And FOIL stands for first, outside, inside, last. And we're talking about terms when we have our quadratic equation written in the form of a product of two different adding or subtracting problems. So, for example, if we have x minus 6 times x minus 2, the FOIL, the first, means we take the first two and multiply them by each other. So x times x is x squared. Then the O for outer means I take the outside and I multiply it by the outside. So x times negative 2 is negative 2x. Then it's the inner, meaning I'm going to take negative 6 and I'm going to multiply it by x, which is negative 6x. And finally, it says last, and so all we're doing is we're just taking our last terms, negative 6 and negative 2. Negative 6 and negative 2 is positive 12. Then we combine. There's no other x squared, so we have x squared. Negative 2x minus 6x is negative 8x, and then plus 12 is 12. So here's my equation right here. So all I've done is I've taken the distributive property and multiplied it a few different ways. So here's an example. It says write a quadratic equation in standard form with x being negative 1/3 and 6 as its roots. So the way we set this up is always the same way. It's always going to be x minus one thing and x minus my other root. Okay, so in our case, negative 3 goes here and 6 goes here. Well, you'll see that minus the negative 3 is like adding, so it's going to be x plus 1/3 times x minus 6. And now all I'm going to do is take my FOIL, my first terms, x times x is x squared. My outside terms, okay? So I take x and negative 6. Then my inside terms. And finally, I have my last terms. So 1/3 times negative 6 is negative 2. So I combine all my like terms and I get 6 or x squared. Negative 6x plus 1/3 is going to be negative 5 1/3 x minus 2. And we could also write, instead of 5 1/3, you could have written 16/3. Oh, excuse me, that's 2/3. 17/3 instead of 5 2/3. Here's a guided practice problem you can write now. Now, the way we solve these using factoring is something called the zero product property. It says if I have this right here, x plus 3 times x minus 5 is equal to 0, it means either this is 0, this is 0, or both of them is 0, because 0 times anything is 0. So the way I solve it is I just say, okay, x minus 3 could be 0, or x minus 5 could be 0. And I solve them to get x by themselves. Just like we did when we were graphing, we found what x is equal to. So let's take this one right here. 16x squared plus 8x is equal to 0. So what I'm going to do is I'm going to say, okay, what can I take out of both 16x squared and 8x? Well, 16 and 8 both have a factor of 8. And x squared and x both have a factor of x. So I'm going to take an 8x out of both. And I factor that out, and I get 2x plus 1 is equal to 0. So the zero product property says that either 8x is equal to 0, and I'll write that right here, or 2x plus 1 is equal to 0. Okay? And so I'm going to get two unique different answers right here for x. So what I'm going to do is if I divide by 8, 0 divided by 8 is just 0. So x can either be 0, or I subtract 1, and so I get 2x is equal to negative 1, and then divide by 2, and so x is equal to negative 1/2. So the two possible answers for my x that would make this equation equal to 0 would either be 0 or negative 1/2. Here's 3 guided practice problems you can try as well. Now, there is special unique situations that come with our factoring of quadratics. Here are a couple examples of what are called perfect square or difference of square quadratics. Now, the way I factor goes like this. I look at the number in front of x squared, and I look at the number at the very end. Okay? And so what I do is I multiply them. So 1 times 64 is 64. Then I take a look at the middle term. Okay? And I get 16. And so what I need to think of are what are 2 numbers that multiply to 64 and add to 16. So I can think of all the factors of 64. 1 and 64, those don't add up to 16. 2 and 32, those don't add up to 16. 4 and 16, they don't add up to 16. But I do know which ones do, and that would be 8 and 8, right? 8 plus 8, 16. 8 times 8, 64. So what that means is that I can write it like this. I would write x plus 8 times x plus 8. Okay? And so what this is saying is that this is going to be equal to 0. So that means that either x plus 8 equals 0 or x plus 8 equals 0. It's the same thing, right? So I'll say x plus 8 equals 0 or x plus 8 equals 0. Okay, subtract 8 from both of them, from both sides. You get x equals negative 8. And it's actually negative 8 2 times, so we only have to write it once. Okay, so the only root that is, the only root for this equation is negative 8. And so if we think of it as graphing, since it's the same thing, it's negative 8, that would mean that its vertex is sitting right at x equals negative 8 on the x-axis. Let's look at letter B. Now in this one, it's not equal to 0 yet. And anytime we solve, just like we did when we were graphing, we want it equal to 0. So what I'm going to do is I'm going to subtract 64 from both sides. And I get x squared minus 64 is equal to 0. Okay? So I look at this again. Okay? I always look at the number in front of x squared and my last number, and I multiply them. 1 times negative 64, remember you have to include the negative, is equal to negative 64. And my middle term, there's no just x term, right? So it's adding up to 0. So what are 2 things that multiply to negative 64 and add up to 0? Now here's a hint. I've done enough of these in my life to know that whenever it adds up to 0, it's going to be the same thing, just a positive and a negative. And the nice thing is I have a negative here. So what 2 things multiply to 64 that are the same thing? Well, that would be negative 8 and positive 8. So I go back and I write it out in the factored form. It'd be x minus 8, x plus 8. Okay? And so in this case, it's equal to 0. So either x minus 8 equals 0 or x plus 8 equals 0. And so I'll solve them both. X minus 8 equals 0, x plus 8 equals 0. So how do I solve them? I add 8. And so x could equal 8, so I subtract 8, and x equals negative 8. So if you're thinking of graphing again, where did these cross the x-axis? They cross at positive and negative 8. Here's a couple examples that you can also try.